Hi folks, Bill with 3DChameleon. In today's little video here, I'd like to cover PrusaSlicer and how to use it with the 3DChameleon. Now what I've done here is I have downloaded our profile here for the Prusa Mini. We call it the Quad Mini. And in this profile, I'm going to go ahead and walk through all of the settings that we've changed. Basically on the Prusa Mini, we've changed just a few things. In this particular example, I'm only running it at 0.3, but you can actually go, we have a 0.25 as well, and whatever other settings you want to use. You can really just take any of these default settings and just make some minor tweaks to them to get them to work. Now, the interesting thing about the Prusa is that it's obviously a single color. So the very first thing that we had to do is we had to go over here and modify it to support 4 extruders. And check the box that says it's a single extruder, because the 3DChameleon is just a single extruder that actually emulates 4 others. So back over to our printer settings. Really nothing has changed in any of these settings. We're not using ironing. You can use ironing all of those fancy features in here. They'll all still work, no problem. Skirting and brimming, nothing really changed. Support material, we're not doing anything in particular fancy here either. Speed-wise, you're going to run your printer at the normal speeds, no problem with that. You'll notice that we have this multiple extruders setting, and in my case, I actually have the wipe tower enabled. In some cases, maybe you want to do edge purging. If you want to do that, then you would turn this off and modify your G-code to facilitate that. The other thing that you want to do is you want to make sure that you have enough purge area here. So I'm using a 60mm width with a 180-degree rotation, and what that's doing is that's when I load in a part, you'll see it's going to place a purge block here on the back side. And you can move it around. That's why these numbers aren't exactly even. You can drag it and place it wherever you want to. But you want to make sure you have enough volume and width of the purge block so that the purge block has a proper width and width and depth, so that you can actually get it to stick. You don't want one that's a very narrow and 5mm wide, 200mm tall part, for example. You don't want a purge block like that. You want it as square as possible, if you will. A couple of things to note: no sparse layers. This is an experimental feature. I am running Alpha 1 of the Prusa 2.3. There are later versions of it, but we haven't tested those just yet. But this should, everything that we're going to show you in this video should be pretty consistent across the board, all the way back through 2.0 versions of PrusaSlicer. But the no sparse layers is experimental, and interestingly enough, sometimes it works and sometimes it doesn't. So you'll want to play around with that. Basically what this does is it eliminates a lot of the empty space that is wasted height, if you will, of a purge block. Say, for example, you have 10 layers, but you only have 4 color changes. There's 6 layers that are actually going to be printed just in the regular color that you're on, even though they're not needed for purging. It's just there to build the tower up so that it maintains the height of the model that you're printing. But if you turn that no sparse layers on, that should actually eliminate those 6 layers where you're not actually doing anything. But we found that sometimes that does and sometimes that doesn't actually work. And it's going to be dependent on how you have your extruder configured. Now, in this case, we're talking about the Prusa Mini, and the Prusa Mini has a very odd-shaped extruder with a footprint that could interfere with it. So I'm pretty sure that's why they have that limit there, and it's going to be very dependent on where you place the part and where you place the purge block, whether it can actually turn that sparse layers on or off. I just leave it off for now. This last one, the prime all printing extruders, you want to make sure you always have this one off. Priming all printing extruders in PrusaSlicer actually adds a lot of artifacts. A lot of other things get turned on that you really don't want turned on, and they will mess things up. So turn that off and don't even bother with that one. We don't really have any changes here in the advanced settings. The output options, this is where we actually have something very important. We have our Python script that we call ReverseDrive. And the idea here is that this is a post-processing script that runs against your code when it completes slicing, or technically in this case it's when it's exported. The idea here is that on the 3DChameleon we have a 4-drive solution, and we have 2 forward-facing extruders and we have 2 rearward-facing or backwards-facing extruders. And what we need to do is we need to modify the G-code to drive those 2 backwards-facing extruders. And we'll see a little bit later on in the custom G-code that there is a block of code in there that gets injected to tell the ReverseDrive when it is needed to reverse the 2 extruders, so that they technically aren't reversing, it's reversing the reversal that we did. So it corrects it back to normal. And I'll show you that in the code. So there's nothing else in here. So that's just our profile. Let's go over to the printer settings. As I mentioned before, we have the extruders set to 4. Well, in our case, it's only 4. But if you might have 2 chameleons on your machine, then you would go to 8. Everything else, we just leave the default. We want to make sure we're using relative E distances. That should be checked. We are not using firmware retraction. We're not using volumetric extruders. You're more than welcome to use the variable layer height feature. The slicer will take care of everything else on that. That's fine. Our machine G-code, our starting and stopping G-code are unchanged. We don't modify those in any way. The magic of all of our code is down here in the tool change G-code. And I'm going to copy all of this code out, and we'll put it in a text editor so we can actually walk through each section inside of here and see how everything is working. So if we start off here, you'll notice that we have the top line here is 3DChameleon tool with the value of next extruder in there. Next extruder is a variable that PrusaSlicer will replace with the extruder that you're switching to. Likewise, we also have previous extruder, and it will do the exact same thing. It will inject into this block of G-code the number of the previous extruder. You'll notice that in some locations we have square brackets and some we have curly braces. I'm not entirely sure why they're like this, but some slicers actually require different types of parameters. But the start of our G-code really is starting with this M82 line. M82 indicates to the system that we're going to be moving the extruder in absolute positions. So we're going to move it to a particular location as opposed to moving it a particular distance. So we'll then go ahead and reset the extruder to 0. And then the first thing that we do when our G-code starts is we move the nozzle over to the back center of the printer. And the reason for doing this is when we load and unload the filament, we don't want any filament that's dribbling out, if you will, to mess up our part. So we're going to move it behind the purge block. That way when we actually do resume printing, it's going to move from that location back into the purge block, and it will wipe it off on the back side of the purge block and away from your part. This is always a good idea. So whenever you're actually moving the purge block, you want to make sure you move this location to the other side of the purge block away from your part. That way it always crosses over the purge block, which helps to wipe the nozzle off if there's any stuff running out of it. The next thing that we're going to do is we are going to retract the filament out of the nozzle. But this is a complex procedure, as you can see here. We actually have quite a bit of code involved in doing this. And this code does basically 2 major things. The first thing is it pulls it, I should say 3 major things. The first thing is it pulls it out and it allows it to slowly cool down in the 1.8 millimeter diameter tube that we include in each of the kits. By constricting it, by allowing it to be cooled down inside that 1.8 millimeter tube very slowly, What that does is it allows it to take shape into a smaller diameter than the entire rest of the system. The idea here is that we don't want PLA swelling up so much that it can't go back into the smallest diameter of the system. So we will very slowly, continuously move it inside the 1.8 millimeter tube until it's solid enough that we can actually start working it, basically by shaping it. So the next line, this G0E1, moves. After we've pulled this out 80 millimeters from the nozzle, we then move it very rapidly back into the nozzle, right at the tip. We pull it back out again, and we ram it back right into the tip again. And we do this a couple times just to make sure that we're eliminating any blobs on the end of the filament. If you pull out filament while it's still warm, it could actually separate and have the liquid portion come off of the end of the filament. And if you don't do this correctly, that filament will actually create a blob several millimeters or even centimeters down from the end of the filament. And we don't want that. We want to eliminate those. So these two maneuvers actually force the system to actually go and pick that back up. We then do those two maneuvers very, very rapidly, just tapping it very quickly. If you think about removing tape from a table, you accidentally got some tape on it. The easiest way to get the tape back up is to use a fresh piece of tape and pull it up with it. That's kind of what we're doing here. We're just very rapidly touching it, pulling it up, touching it, and pulling it up. So these lines are all involved with cooling it into the 1.8 millimeter shape and then actually eliminating the blobs that are at the tip of the filament. Now that we've done that, now we'll go ahead and pull it back out very slowly again, 80 millimeters, but at a much slower rate. In this case, it's a feed rate of only 100. Previously, we did it at a speed of 600. So this allows it to get very solid in the tube. And we pull it out to 80 millimeters. Once we've done that, the next thing that we're going to do is we're going to pull it into the 3DChameleon's Y adapter. And what this will do is this will allow us to make sure that it fits inside of the tubes and fits inside of the Y adapter. And it does it while it's still just a little bit soft. It basically brings it back to 170 millimeters, pushes it back to 110, and then repeats that, brings it back to 170 and pushes it back to 110. These allow the filament to actually pass through the Y adapter and or the PTFE connectors, just to make sure that it is narrow enough to fit through the system. Once we've made it past that, we now know that the filament A has the correct tip shape and B is narrow enough to fit through the entire system. We will then go ahead and slowly back it back out an additional 120 millimeters. Now you'll notice that we're doing it in an odd way. We're doing it in minus 80 millimeters and minus 50 millimeters. And the reason why we're doing it in two of these is the Marlin firmware on some printers does not allow you to move the filament greater than 100 millimeters at a time. And you'll notice that nowhere in any of these do we actually do that. But this maneuver actually is supposed to be 130 millimeters. So we just broke it up into two groups. And later on, when we reload the filament, you'll see where this 55 or this 50 comes into play. This is where we're actually loading it back in the last 50 millimeters. You can actually tune this value to place the filament exactly where you want it. And actually, there's another way of doing it, which we'll get to. So the next block of the code, this is now that we've removed the filament, now what we need to do is go and load the new filament. In order to do that, we're going to use the printer and use the ability of the printer to move something to touch our command button. Now on the Prusa Mini that I'm documenting here, the command button is on the front of the Y-axis. So what we're going to do is we're going to display a message to the user, what tool we're loading. We'll then go ahead, in this particular example, we're going to always reset the extruder to the very first color. So the way we do that is we press the button for 1 second. So here's how this works. All of the commands that we're going to be passing it are this exact same block, but we have a couple different variables in here. The first one is, where are we going to place the, in this case, the build plate before we're pressing the button. I want to get as close to the button as possible without pressing it. Then the next few lines of code will actually press the button, and then we'll move back off of that. So in this case, we're going to move the build plate to 177, and the button in this case triggers at 180. So we're 3 millimeters short. So in this case, we're kind of losing 3 millimeters short of the build plate. You can go all the way down to 1 millimeter. Heck, on some systems you can get even closer than that. But I'm just doing it for 3 millimeters, just a nice safe value here. With a speed of 2,000, so this basically pretty quickly moves the y-axis to this 177 position. And in this case, the y-axis is the build plate. Then we're going to go ahead and press the button. This next line right here actually presses the button. It moves the build plate to 180, which engages the limit switch, and does that at a speed of 500 millimeters per minute. So, so we go and we press the button. That's 1/4 of the speed we were at. We then wait. G4 is a wait, or what they call dwell, for a value of 800 milliseconds. So we're waiting for 800 milliseconds, and then we're immediately moving back off of the button back to that 177 value at the last speed we typed in, which is 500. So it's going to move, press the button, wait, back off the button. Now this says dwell for 1.1 seconds, but I only put in a value of P800, of 800 milliseconds. The reason why I did that is because there is a mechanical motion involved in these, and as we're pressing the button, it will engage the button, and we're still moving. So that's going to take up that remaining 1/3 of a second that we have between our 1.1 seconds and our 800. Now technically, to issue a command to reset to extruder 0, it's a 1 second pulse. So as long as we're above 1 second and under 2 seconds, this is going to work just fine. So in this case, we're looking for that 1.1. We can adjust this value. If, for example, your printer is a little slower, you might actually need to make this a smaller value. Or if your printer is too fast, you might need to make this a larger value. You might make it 1.1 seconds. Those are going to be values that you're going to tune. The last line in this block is another dwell command. In this case, it's actually going to wait for 3 seconds for the button to actually be pressed. Okay. So notice that this is a P value, which means milliseconds, and S means seconds. So this command is going to wait for 3 seconds for this, or this G4 command is going to wait for 3 seconds for the machine to reset back to extruder 0. So once we're back at extruder 0, either the system is going to load the filament or it's going to load in the next color. So if we were already at extruder 0, it's going to go back to extruder 0. It's going to load the same filament. You'll see this only at the beginning of a print. But normally, after it goes back to 0, it's wanting to go to one of the others. And that can be extruder 1, 2, or 3. Remember, there's 4 extruders, and they're all labeled or numbered 0 through 3. So if the extruder is not 0, in this case if the value is greater than 0, then we know that we have to press the button one more time at least. In fact, for every extruder 1, 2, and 3, we need to press it one time, or 2 times, or 3 times. So all we're doing in our code is if we need to press it one more time, we press it. And we just keep pressing it until we get to the desired extruder. Now these last 3 button presses are actually not for 1.1 seconds. 1.1 seconds tells the system to reset to extruder 0. But to go forward, to count up the extruders, we're only going to press it for 1/4 of a second. So what we're going to do is we're going to move to the same value. In this case, it was already there. We're going to press the button, but instead of waiting for the 800 milliseconds that we did on the extruder 0, we're only going to wait 100 milliseconds. And remember, we add a 0.3 seconds to this to to get it to trigger. We're only looking for a quarter of a second, so if we're between a quarter of a second and 1 second, it's going to advance to the next extruder. So in this case, with the 300 millisecond delay plus the 100 millisecond dwell time here, what we actually wind up with is about 400 milliseconds total. And that's enough to make it move to the next extruder. We then wait for that command to happen, much the same way we waited for 3 seconds for it to go all the way back to extruder 0. In this case, to move to the next extruder, it only takes about 3/4 of a second. So we're just pausing 3/4 of a second for that to occur. We then press it a second or a third time to move to the second and third extruders. And once we've made it there, we then go to this line here, which is actually just a comment, but it's very critical to the processing of this system. This line should never be modified or removed. The idea here is that we are telling the post processor that we put on the in the slicer earlier, that's that ReverseDrive Python script. We're telling it which extruder we're moving to, and it knows based off of that which drives to run forward and which drives to run backwards. Now, as an example, once we've loaded the extruders, what we have here is a command. We then basically turn on our post processor with this command, and it knows then to keep these the same as a positive value, or it knows to reverse these values by making them negative values. That's something that we don't have to worry about. It's all automatic with the system, but this line is critical to make sure that that works correctly. Okay, so now that we've got to that point, we've unloaded, we've selected the new extruder, we now need to load the filament back into the system and resume our print. This bottom block of code here is the one that reloads the filament back into the extruder. And just as I said earlier, where the commands are maxed out at 100 millimeters, we're only loading 100 millimeters at a time. So if you do the math and add up all of these motions that we did here, you actually wind up with 250 millimeters of backing out of the filament. Well, we're reversing that and we're loading 250 millimeters. In fact, you can see there's 100 millimeters here and the second 100 millimeters here. So now we've loaded 200 millimeters. But here's where something interesting happens. In this case, we're loading 55 millimeters instead of 50 millimeters. We're loading the 55 millimeters because we want to make sure that we've loaded enough filament. So every time we load, we're actually adding just a little bitty extra blob of filament that we're going to squirt out at the end of the nozzle. And this is the reason why we actually, at the very beginning here, move this extruder back off the purge block, before the purge block, and on the other side of it so that it doesn't affect your part. So what this is going to do is this is going to create a small blob of filament that preloads 5 millimeters. Now, if you don't want that much filament extruded, you can actually tune this value right here. This E55 is the important one. You can make it 53 or 54, whatever it happens to be. It could be even 50. But when you do that, you want to make sure you also adjust where the extruder is actually at. So, for example, if you set this to 50, you're going to set this to 0. So that last digit, 0, is also going to be this digit here. So if you set it to 53, you want to set this value to 3. That way it doesn't automatically create a blob before that. So generally, I just leave this alone, and you should never have to worry about it. Once we're done with that, we're going to return the extruder back to its relative distances that we're used to printing with, and basically display a message to the user telling them that we've successfully switched to that color. So that's all there is for the G-code. Let's go ahead and go back to our slicer here. And I noticed a little mistake I must have typed in as I was playing with this. Let me correct that real quick there. That should be a semicolon there. Okay. So now with the we have our tools change G code. Our machine limits, I want to make sure that we do this correctly, so I want to, for some reason Prusa wants to emit G-code, emit these values to G-code. I prefer not to do that. I'll use them for time estimation only, but I don't actually inject these values into the G-code. It's just a little easier way of dealing with this. This makes your printing doesn't get messed up. It isn't necessarily going to be an issue on a Prusa machine, but I have seen, for example, on the Creality machines where they have values that are not realistic in there, and that causes issues. For example, they have maximum accelerations on, for some reason, of very high values of like 10,000. Which far exceeds what the machine's capable of actually doing. And these values are actually overriding the hardware limits that the manufacturer designed into it. So the nice thing is just recently they've added this option to allow you to change that. And I would highly recommend you check those values to make sure that they're consistent with what your machine is actually capable of. The extruders here, this is basically the stock extruder settings. We've just duplicated them a few times. You can adjust your retractions. Make sure when you do that, though, you adjust them for all the extruders. But pretty much we just leave this alone. The only thing I did do is change the colors of these. And I'll show you a quick way of changing the color here in just a second. The next thing is on the single extruder multi-material setup, we actually have all the values set at 0. The reason being is we actually do all of the work in our own custom G-code. Technically, you can actually do this, a lot of that work that we're doing in our custom G-code inside of here. But in our particular case, because we support multiple slicers, we use the same block of code on all of them. And the only thing that we have to change is the parameter names. Everything else actually works pretty much the same. So there's really no reason to use this one. And then there's really nothing else inside of here. So let's go ahead and go back to the beginning here, and we will go ahead and load a model and actually print it. So let me go ahead and load our little, well, I created this test block. You'll notice it's just a simple little square, and I created 4 of them. And let's just go ahead and open up all 4 of them. And you'll notice that when I open up an object that is multi-parts like this, Prusa recognizes that and asks me if I would like to load them as a multi-part object. For this to work correctly, you want to say yes. And you'll see what it's done is it's actually loaded our object. And in fact, it's actually loaded 4 of them. And there, as I move the cursor off of it, you can see they've selected, each one of them has picked an extruder. So when we set up for colors, we actually get 4 extruders and we can pick the materials that we want. Now, one of the really nice things about Prusa is that we can actually double click right here on these color blocks and we can change the color of the filament of that particular extruder. So in this case, I have red. Let's go back to blue on that. So I can change that, and that changes in the model. Now what I've actually done is I've loaded up our printer with these exact colors. So tool 0 has yellow, tool 1 has purple, tool 3 has blue, and tool 2 has blue, and tool 3 has green. And those match my printer exactly. So now you can also see that purge block here and its size. You can see how it's 60 millimeters wide. I can move that wherever I want to. Now remember, the placement I did of the object in my G-code, I'm sorry, not of my object, of my pause area, right, at the very beginning here is 90 and 177. That places that right here back in the middle. So 177 is basically 3 millimeters from the back of the build plate, and 90 puts it roughly right in the middle. This is 180 millimeters wide. 90 puts it right there. So the nozzle is going to go right to this middle position behind the purge block and wait. It's going to do all its loading and unloading from that point. Notice that it's on the other side of the purge block. If, for example, I move the purge block over here for some reason or wherever, then I want to move that point onto this side. And the reason I'm doing that, like I said, is that I want this nozzle to rub across the top of this before it ever gets to our printed part. That way it cleans off any debris that might have dribbled out or was accidentally extruded between the tool color changes. So, but for now, we'll just put this right back there. Let's go ahead and slice this. So there I have my slice file. And with my slice file, I can save this now out to the USB drive or the SD card, depending on what kind of a printer it is. You can see each one is color-coded and matches the color of the extruder. As we go through here, you can see in this case there's no infill, it's just a solid object. But it also is doing this skirt line as well as the purge block, and you can see the purge block is changing colors based on what it's actually doing, what color it's changing to. You notice we have 4 colors, but you only ever need 3 in the purge area because you're always switching to, quote, the next color, right? So we start off with yellow, then we switch to purple, then we switch to blue, then we switch to green. So yellow, purple, blue, green. And then on the next layer, since we're already finished with the green, we can actually do one more green layer here. We don't have to actually switch to the green on the next layer since we're already there. And you'll see that all we did was we unloaded a little bit of the green and then we switched to whatever the next color was. In this case, probably blue. So as we go through there, then you can see how it's changed the colors. Now, admittedly, this is not an optimal scenario. You might have, a build plate full of parts, but this is just a small piece just to show you a color change. You could load in, obviously, way more complex models, and you're pretty much going to get the exact same thing. As an example, let's go ahead and load in a model, and let's just clear that one out. We'll load a new model. Let's see. I'm sure I've got something out here we can go find. So again, it's asking if it's a multi-part. I'll say yes. So it's here's our model. Let's go ahead and back this up a little bit. And let's see what it is. Slice. And there you go. So there's our model. So we have 4 colors. It's one of the characters from Among Us. I don't know if this is the imposter or not, but so there you can see we have the 4 colors in there, and it's automatically taking care of generating all the code we need to build that. There you go. There's a little bit of infill there. You can see how that joins those up real nicely. So let's go ahead and load up this other part. Let's switch back over to the printer and see how it works. So here is my printer, and I copied that file to the thumb drive here. Let's go ahead and load this into the printer. And you can see it's actually showing an image of that tile machine. Now what I've done is I have simply loaded filament into the printer up to, here we can load these up so a little closer so you can see. There's one there, one there. We have our purple and our blue. There you can see the blue. I just typically load them about 1 inch before the Y adapter here. The yellow filament is actually loaded all the way into the printer. And the other thing that I'll do is I will go ahead and hold this limit switch here for 1 second. You hear that grinding. That's actually the machine resetting back to its extruder 0, first color. And if I wanted to switch colors, it's just 1/4 of a second. You hear that quick little switch. There's another switch. There's another switch. And now I'll go back to extruder 0, a 1 second pulse. So there it's reset it back to the beginning. Now we've got 2 different sets of G code. The one I showed you always goes back to the first color between each color change. The second set of G code actually will always, it knows where it's at and it knows where it's going, and it will determine the best method of getting there. That allows you to actually have a quieter scenario or what I call a more reliable scenario. Going back to extruder 0 every time resets the position every time, so it knows exactly where it's at. But the second one is there's a possibility you could get lost So it's just it's a trade-off of quietness over reliability. So let's go ahead and hit print on this. And now the machine is heating up. So the other thing I'll do is I'll take my build plate and I'll spray a little Aquanet hairspray. I am a big fan of using Aquanet on these. And what I'll do is a little tiny dusting is all it needs. Now, normally you don't need Aquanet every time, but I kind of like to do a little light dusting just to ensure consistency. The idea here is that if you do the exact same process every single time, then you'll get the same results every single time. So repeatable processes are they're what makes 3D printers work. So we are heating up now. We're 42 on the build plate, and this is going to go and do the typical homing with the Pinda probe on the Prusa Mini here. So it heats up to 170 on the build plate, does its probing, and then it goes back and heats the rest of the way. So let's go ahead and let this heat up the rest of the way. We're about 10 degrees away on the build plate. I might add, this is the installation of the Prusa Mini, where we have the Chameleon electronics installed here. We have the Chameleon installed as a direct replacement for the Bowden tube. It is a Bowden tube system. You do have the option of doing a direct drive. That's a little bit more difficult to install on here. We found that this one works just fine, so I actually prefer this setup. It's also a lot faster because you're only backing the filament out to here as opposed to backing it all the way out through and then into the Y adapter all the way out. To us, this is a much cleaner install. Okay, so now it's homing. And here you can clearly see the switch down here. We have our printed mount for holding our limit switch. And our limit switch is wired directly into our electronics. And our electronics are only wired into one of the motors on the 3D Chameleon. The other motor on this installation is the factory extruder motor that we removed from the Prusa Mini extruder. So the way this is set up is it doesn't care what color is loaded at the beginning as long as the color and the extruder are active. So it could be any of the colors. It's going to go ahead and do a purge line, the very first thing, and then it's going to unload whatever color is active and then automatically go back and load in extruder 0 to start the print. So here it's starting that purge. So now it'll unload the extruder. So now it's reset the extruder back to extruder 0, and it'll load extruder 1. It was already on extruder 1, but it's going to continue that. So now what it's going to do is it looks like the yellow wasn't loaded in all the way when I first started the print. So it's not exactly in the right spot, but there you see the purge is, the yellow is coming out. And now it's printing the skirt. Now it'll unload the filament. And here's where that point is where I said it's going to go back to that bottom, the back middle, while it's purging. You can see this little dribble right here that it did. We don't want that on our parts. You can see how clean that transition was from here to here. We want to make sure that any dribbles are caught by any the disposable material here and not on our actual part. So that's why we do that. So now it's going to switch. It's going to go back to 0 and then switch to the second extruder. There we go. And now it's loaded the second color. And now it'll purge the yellow out of the nozzle and make sure that it has enough of the second color, which it looks like in this case is blue. So you'll see the transition from yellow to green because it's mixing with the blue. And there's the, I guess that's a purple it's printing. Yeah, it's purple. So now it'll go and unload the purple. Reset back to extruder 0, extruder 1, extruder 2, and reload. So now we should see purple transition to blue. And there we see the blue filament. You want to make sure your purges are enough in your PrusaSlicer or whatever slicer you're using to fully expel all of the old color. In this particular case, in our default profile, we're pretty conservative. We have actually quite a bit of purge. You can actually dial that down or increase that depending on what your needs are. So now we're going to switch to the last color, which would be green. But in this case, you can see we've got quite a bit of purge for a small area. The area doesn't make any difference, but the important thing is you can see the clear differentiation. There's no bleed over between the two colors. By purging enough, you can actually ensure that you get a good quality color transition. If you don't purge enough, you'll see that, for example, let's say you're switching from blue to yellow, and what will happen is you'll see a lot of green or blue debris left over in the yellow if you didn't do that clear enough. So now we switch back to 0, to 1, to 2, and now finally to 3. And now we're loading the last color. So you can see the command sequence is very simple. We're just pressing the button in a sequence, a long sequence to go back to 0, a short sequence to go to the next color. Now, if you were doing this as a direct drive, there are 2 more sequences. There's a 3-second pulse and a 5-second pulse. Those pulses are going to be depending on whether you're loading or unloading. A 3-second can load or unload your extruder, and a 5-second can load or unload, depending on if you're going forward or backwards. So there we can see we got a good transition from blue to green. Now technically that was plenty of filament there, but we've got another, twice that amount here, which ensures a very good transition, but it wastes a lot of filament. Again, that's a trade-off that you're going to have in your slicer software. The strategy that your slicer software uses to do purging can be wasteful sometimes. PrusaSlicer is very good. You can tune these values. You can tune them from one color to another, depending on what color it is. So for example, you can have what we call strong colors or weak colors. A strong color is going to be something like a black that's going to bleed over onto everything. And you need to purge a lot to get black out. But you also don't need to purge a lot to get into a black. So for example, if you have a red going to a black, you might have a very short amount or small amount of purge material that you need to do that. But if you're going from the black to the red, then you're going to need a large amount to get rid of all that black. So you can tune those in your slicers. So there it just did the second layer of the green. And now it'll go ahead and remove that. You'll notice that we only have 3 colors here in that 3 primary colors, not the outside one since we started with that. But as we move on, you'll see that there's only going to be 3 colors on every transition here, for every layer. So that is pretty much the software in a nutshell. You can see how I loaded the models and how I selected the colors. And I just hit print, save that to the USB drive. I plugged the USB drive into the printer, and the printer is duplicating exactly what we asked it to do. Thanks for watching. Oh, by the way, down below in the video is the profile that we use for this process. We will have other processes for the other types of printers, not all printers, but this is just an example. We'll have another one for the Creality style machines, and we'll have another one for the Prusa Mark III. Thanks for watching.